We've learned about the composition of the atmosphere in previous lessons, but did you know the atmosphere has several layers with very different characteristics? The atmosphere is made up of 5 layers which contain all the gases that protect us from the dangers of outer space. The lowest layer of the atmosphere is called the troposphere. This is where almost all weather occurs. The troposphere begins at the Earth's surface and extends to anywhere between 4 and 12 miles high. The varying height gives this layer more of an egg shape, with a height of about 4 miles at the poles and closer to 12 miles at the equator. In the troposphere, density decreases with height, meaning as you go up in altitude, the temperature decreases and the air becomes thinner. Just to give you an idea of the temperature change, by the time you reach the top of the troposphere, or tropopause, the temperature will decrease to about minus 60 degrees Fahrenheit or minus 51 degrees Celsius. The stratosphere extends from the tropopause up to about 31 miles above the Earth's surface. In this layer, temperature increases with height due to the creation of ozone that's present in this layer. The increased temperatures make the stratosphere a very stable atmospheric layer and give thunderstorms their famous anvil-shaped tops. The next layer of the atmosphere is called the mesosphere. The mesosphere extends from 31 miles to 53 miles above the surface of the Earth. This layer is where most of the meteors burn up in the atmosphere. Temperatures once again decrease as altitude increases, similar to what happens in the troposphere. The thermosphere is next and extends from 53 miles up to 375 miles above the Earth. Being one of the outermost layers, the air here gets bombarded with ultraviolet and X-ray radiation from the sun, which, in turn, causes a large temperature increase, as high as 3,600 degrees Fahrenheit at the top. The last layer of the atmosphere is called the exosphere and is the outermost layer. It extends from the top of the thermosphere to 6,200 miles above the Earth. In this layer, atoms and molecules of the atmosphere escape into space. The atmosphere is important, but we need to also look at the big picture. Here is Earth. The sun heats the Earth, but it does not get heated evenly. At the equator, the sunlight is more direct and heats the surface the most. Out toward the poles, the sunlight is spread out over a larger area, so that area won't heat up as much. This creates an area of rising air at the equator, which in turn creates surface flow from the poles to the equator. This simplified circulation pattern is just a concept. The rotation of the Earth changes everything. The Coriolis force, a force created by the rotation of the Earth, causes the circulation of air to flow and break up into 3 distinct cells. In the northern hemisphere, the Coriolis force acts to turn the wind to the right. The circulation pattern is what gives rise to the westerly flow over much of the U.S. from 30 north latitude to 60 north latitude, and the easterly flow from the equator to 30 north latitude. There are several other factors that can also affect the circulation of air. Things like seasonal changes, topography, and friction from objects on the surface. The Earth's circulation patterns always try to maintain a balance. This means that air flows from the areas of high pressure into areas of low pressure. This causes both horizontal movements of air, called wind, and vertical movements of ascending and descending air. In the northern hemisphere, a low-pressure system will have air circulating counterclockwise as it flows into the center. A high-pressure system will circulate clockwise as it flows away from the center.